Hello everyone, it is Stalemate here, and welcome to the first episode of It's a Math Miracle. In this series I'm gonna try to showcase some things that are math related that just don't seem like they make sense, but they do, and it's a miracle. So, in this episode of It's a Math Miracle, we'll be looking at the chaos game. Numberphile did a very good video on this, so check that out after this video. So, here's how the chaos game works. You have 3 points forming a triangle, and then you pick a random point, so let's say right here, and then for each iteration, you're going to go halfway between a random point. It has to be one of these 3. So, let's say this point up top is chosen. I'll go halfway to there, and then maybe this one is chosen. So then from here, I'll go halfway to there, which is about there. And let's say it picks that one again. And then maybe this one, so here. And then this will just keep going on and on. But something interesting happens if you keep doing this long enough. And you'll see in a minute what I mean. So, let's say you just keep doing this. It's boring just watching me place random dots. So I'll switch to my code that I have, some code that I have up here. It's about 56 lines. This will show you the craziness that emerges when you let this run. Let's set this to 60, I guess. And let's play. Let's see what happens when you let the code just randomly pick a point and then go halfway towards it. So you can see starting to notice a fractal emerge. This is Sierpinski's triangle, and I find it very weird that when you just pick a random point and go midway to it, it'll form Sierpinski's triangle. So I was surprised, very surprised when I saw this for the first time. I just couldn't, I don't know. It just didn't seem real, but it is. It's a fractal emerging from chaos. And I guess now I'll show you my code. So this is where we import all of this stuff. So we set the screen to be a width of 1200 and a height of 800, and then we made a clock so it can do that. Then we did our colors. So this function define draw RGB points. This basically just draws those red, green, and blue points that make the triangle. And then the new point, this is what actually makes a new point, if you can see. So it'll pick a random of the 3 red, green, and blue points, which is what this line does. And then it'll go halfway to that point. So yeah. So dx, which is I forgot, but whatever. You basically know that this is what makes a new point. So yeah. And then this is just your while run loop that just does everything. So here, it'll just pick a random point if there aren't any points. So yeah. So that's basically how this works. And I just want to run this with a higher frame rate. Let's say 200, and then we can see the triangle come out quicker. And it might not look the best. Like, I just manually picked 3 points because I'm not that I'm not that good at coding, so yeah. But anyways, you do get this, and this is very cool. Sometimes it might not look that good if the first point is just out here in the open. That kind of breaks like the triangularity, I guess. But other than that, I think this is very cool. It's just mind-blowing how like something very uniform and like I guess perfect, not really perfect, will just form out of randomness. So yeah, and I also want to explain like why it does create the Sierpinski's triangle. So I might not do a good job at explaining, but I'll try my best. So it just picks a random point, and to make the Sierpinski's triangle or Sierpinski triangle, like all of the points have to be within the triangle. So if you just let it run long enough, it'll eventually make points that are in the triangle. So it picks a point here. So this is in the triangle, the gray Dorito. Anyways, after it's in here, it has to go to the outer edges at some point so it can actually make a triangle shape. So I won't like demonstrate that but yeah. Anyways, the reason why it usually doesn't put anything within this triangle is for it to do that, since it only goes halfway towards one of the random points. I'll just erase some of this real quick. It has to like pick a point like right here to like go inside of the triangle, and a point can only be here if it hasn't gone in the triangle yet, which is like very unlikely. So after it goes in the triangle, it can never go back out. So once it's in, it can never put anything in here because this is not like midway to any of the points. And the same reason is true for like any of the sub-triangles, I guess. Because if you let this go for a few iterations, eventually you'll have a point that's like right here, or somewhere around there. So you can just recreate this scenario, but like down a level, I guess. So that'll cause it to usually never go in any of these triangles. So yeah, that's basically the very bad reason, my bad explanation as to why this happens. And yeah, goodbye.